Alright, you're welcome to my YouTube channel. Remember, I'm still your boiling point. Please, we are going to be entering another topic in physics, which is chapter 1, unit and measurement. Please, if you've not subscribed to my YouTube channel, do well to subscribe, please. Then hit the notification bell. So, meanwhile, let's start with unit and measurement. So these are all the questions under unit and measurement. So this is the part 1 of it. So question number 1, which of the following have the dimension as Planck's constant? Planck's constant. Option A, force over distance. Option B, moment of force. Option C, moment of momentum. Option D, moment over distance. First of all, you need to understand the concept of Planck's constant. Planck's constant is coming from Planck's equation, which is E. Can you still remember this? E is equals to hf, where E is the energy, h is the Planck's constant, while f is the frequency. And you know that there is a relationship between frequency and period, which is time, in which frequency is 1 over t. That means any place I see frequency, I will put it as 1 over t. So I have that E will now be equals to h times 1 over t. And what is h times 1 over t? I will have it that E is equals to h over t. So we'll make h the subject of the formula. You will now have that h is equal to E times t. So h will now be, what is E? E is the energy, right? So we'll got to look for the dimension of energy. I know that energy is also force times distance. I'll have it as force times distance times time. So what is the dimension of force? mLt by 2. That is dimension of force. What's the dimension of distance? Times L. What's the dimension of time? Times t. So I'll have it that L times L is L square. So 1t, we cancel 1t that is here, right? Yes, I'll have it as t by 1. So the dimension of Planck's constant is m L square t by 1. I repeat, m L square t by 1. So I will write it somewhere here, because this is the dimension of what we're looking for. m L square t by 1. So let's check the options and see which one will correspond with all these or the dimension that is written on the board. So option A, they say force over distance. So option A, let's see option A, force over distance. Force over distance. What is the dimension of force? m L by 2. What is the dimension of distance? L. This L will cancel this L. What is remaining? mt by 2. So is this thing corresponding with this? No. That means option A can never be the answer. What is option B? Moment of force. Moment of force. Moment of force. Moment of force is known as torque. Torque. Moment of force is known as torque. Remember. So we call it moment of force, which is force times distance. What is force here? mLt by 2 for force, times it by distance, which is L. I have it as m L square t by 2. So is it corresponding with this? No, it's not corresponding with this. So it cannot be torque or called moment of force. Option C is moment of momentum. Moment of momentum is also known as angular momentum. So I have it as momentum times distance. So moment of momentum is momentum times momentum times distance. It is called angular momentum. That's what it's called. So what is momentum? Mass times velocity times distance. So the dimension for mass is m, dimension for velocity is lt by 1, and dimension for distance is l. So L times L is L square. I'll have it as M L square T bar 1. Is it corresponding with this? Yes, we have M here. L square T bar 1 T bar 1. Yeah, so I think the answer here is option C. Option C is the answer. Definitely we'll stop here. So we can't go to option D. Because if we still go to option D, which is momentum over distance, so okay, let's still go to option D for clarification's sake, which is momentum, mass times velocity over distance. What is M? What is dimension for mass? M. Dimension for velocity is LT bar 1 over L. This cancel the which is MT bar 1. So it cannot be. It cannot be. So please. Alright. So the correct answer there is option C. Then question number 2. They say the dimension formula for luminous flux. Luminous flux matches with which of the following? A. Momentum. B. Force. C. Rotational impulse. And B. Power. So the question is, what is luminous flux? Luminous flux. What is luminous flux? Luminous flux is luminous energy per time. That's what it's called. Luminous flux. Flux is energy per time. So we got to know the dimension of this energy per time. What is dimension of energy? Remember that energy is force times distance over time. So what am I going to have? I'll have it as for force here, I'll have it as mLT bar 2 times distance, which is L all over T, right? So what am I going to have? I'll have that luminous flux will now be equal to, okay, L times L is L square. I'll have it as M L square. Then this T going up will be minus 1. I'll have it as T bar 3. T bar 3. You get? So we are looking for the dimension of luminous flux. Luminous flux is M L square T bar 3. So I'll have to drop it somewhere. Let me drop it somewhere. I'll have it as M L square T bar 3. So drop it somewhere. Let's solve now. So option A, I have it as momentum. Of course, momentum can never be the answer. Momentum is mass times velocity. Mass is M. Dimension for velocity is LT bar 1. So it's not corresponding with that rubbish. So that's non option A. Option B is force. Force is mLT bar 2. It is not corresponding with that. Option C is rotational impulse. Rotational impulse. Rotational impulse. What is impulse? Impulse is force times time, right? So rotational impulse is force, which is up. In this case, if impulse is force times time, so if we're talking about rotational, that means the force that causes rotational, and the force that causes rotational is called torque. So rotational impulse is something as torque times time. So which is force times time. What is force? mLT bar 2 times time, which is T. So I'll have it as mLT. What am I going to have? T bar 1. We get it. That is called. Is it matching with this? No. It cannot be the answer. So number 4, which is power. Power, which is D. Power. What is power? Which is energy over time. What is energy? Force times distance over time. Let's analyze it. For dimension of force, we have it as mLT bar 2 times dimension of distance is L all over dimension of time is t. So I'll have this as m l square then t bar 3. So is this corresponding with this? Yes, it's corresponding. So here I have m here, l square here, t bar 3 here. So that means the correct answer is option D, which is power. Option D, which is power. So number 3, the following is a derived unit except A, Newton, B, watt, C, meter per second, D, meter. So remember that we have what we call fundamental quantity and derived quantity. Fundamental quantity is represented with this tau CMT. Remember that this T is time, A is amount of substance, L is length, this L is luminous intensity, C here is current, M is mass, and T is temperature. So the unit of time is seconds, the unit of amount of substance is mole, the unit of length is meter, the unit of luminous intensity is candela, the unit of current is ampere, the unit of mass is kilogram, and the unit of temperature is Kelvin. So back to the equation, they said the following is a derived unit except we have Newton. Newton is a derived unit, please. Yes, Newton is the unit of force. Watt is also a derived unit, which is the unit of power. Meter per second is also a derived unit, which is the unit of velocity. Meter, look at it, meter is the unit of length, and length is a fundamental quantity. So the correct answer there is options D. Question number 4. Question number 4. They said which of the following is not dimensionally correct. Which of the following is not dimensionally correct? So how do we get it? We have that E, option A is that E is equals to mc squared. First of all, you need to understand this, that an equation is dimensionally correct if all the terms in the equation have the same dimension. So if I check all the terms in the equation and they have the same dimension, that equation is said to be dimensionally what? Correct. So how do we get energy first? The dimension of energy, remember energy is force times distance. Let's get the dimension. What is the dimension of force? mL T bar 2 times L, right? So I'll have it as m L square T bar 2. So this is the dimension of energy. So I will have that the dimension of energy will now be m L square T bar 2. See the dimension of energy, which is equal to what is the dimension of mass here? M. What is the dimension of velocity? Because C is velocity. The dimension of velocity is L T bar 1. Everything all square. So what am I going to have? I'll have it as m L square T bar 2 is now equal to m, Abby. Then open the bracket, which is L square, then T bar 2. So looking at my right hand side, what is the dimension of energy? mL square T bar 2. Looking at my left hand side, I have mL square. Are they the same? Yes. So this one is dimensionally correct. So but we are asked to look for the one that is not dimensionally correct. B is VF is equals to VI plus 18. What is VF? VF is called final velocity. What is VI? Initial velocity. What is A? Acceleration. What is T? Time. So the dimension of velocity is LT bar 1, right? Dimension of initial velocity is also LT bar 1, plus dimension of acceleration is LT bar 2, times it by time. So 1t, we cancel 1t here. I'll have it as LT bar 1 is equals to LT bar 1 plus LT bar 1. So did they have the same thing? What is here? LT bar 1. What is here? LT bar 1. What is here? LT bar 1. Are they dimensionally correct? Yes, they are dimensionally correct. That means option B can never be the answer. Option C, you have it that S is equals to VT square, right? What is S? S is displacement, which is L. Dimension of displacement is L. What is V? V is velocity. Dimension of velocity is LT by 1. Then I have T square, right? So that means this is times T square. So what am I going to have? One this will cancel this. I'll have that L is equal to LT. So I'm going to have 1 over LT. You get? So this and this, are they the same? No, they are not the same. That means option C is the correct answer. So there's no need for us to move to option D. Now, number 5, they said the dimension of the following physical quantity is the same. Which of the following physical quantity is the same? The dimension: A, pressure and stress; B, work and force; C, velocity and acceleration; D, length and mass. So let's take option A, which is pressure and stress. First of all, if they have the same formula, the dimension will be the same. Instead of wasting our time, what is pressure? The formula for pressure is force over area, right? Now, what is the formula for stress? Stress is also force over area. Therefore, they will have the same dimension. So instead of wasting our time, the correct answer here is option A, which is pressure and stress. Question number 6. The unit obtained by combination of 2 or more basic units is called dash. A, fundamental unit; B, noted unit; C, described unit; D, derived unit. Now, fundamental unit is actually a unit that is independent of other units, while derived unit is a unit that is gotten from other unit, which is fundamental unit. So it is derived. That means it is the combination of 2 or more basic units. So the correct answer here is option D, which is derived unit. Question number 7. The dimension of force. What is the dimension of force? You know that force is mass times acceleration, right? What is the dimension of mass? M, right? What is the dimension for acceleration? LT by 2. Therefore, the dimension of force will not be MLT by 2. Do we have anything like MLT by 2 in the option? Option A is ML squared T by 2. No. Option B is ML squared T by 3. No. Option C is MLT by 2. Yes, which is option C. Now, question number 8. Question number 8. The dimension of frequency is that one they get angry and leave the hole for them. So frequency is 1 over T, right? So the dimension of frequency will T by 1. So do we have anything like that in the option? Yes. Now, this one is hertz. Dimension is not in unit. Do you get it now? So it cannot be A, but the correct answer is option B.